So here we are going to talk about laws of exponents. So what are the laws of exponents? We have the powers with same base, the quotient with same base, the power of a product to a power, quotient to a power, zero power rule, negative exponent rule, fractional exponent rule. So after we are going to finish this discussions, we are going to answer practice problems. So what is the definition of exponents? What are exponents? Exponents are used to show repeated multiplication of a number by itself. For example, 7 times 7 times 7 can be represented as 7 cubed. So, for example, another example, 3 raised to 4 is equal to 3 times 3 times 3 times 3. So that is exponents. So what are the laws of exponents? What are the laws of exponents? Here are the laws of exponents. We have power with same base. Power with same base. The base is this a. Since a, the first term having a base of a and the second term having a base of a, so we have the same term. So all we have to do is to add the exponent. For example, if we have the same base a raised to m times a raised to n is just equal to a raised to m plus n. Meaning all we have to do is to add the exponents. So if a has the exponent of 2 times the same base a raised to 3 or a cubed, this will be equal to a 2 plus 3 is equal to a raised to the 5th power. So that is what we call the product with the same bases. Okay, what about quotient with the same bases? When we say quotient, we are dealing with division. So here it is. Here is the rule. If we have the same base a raised to some exponent n, let's say m, divided by a raised to some exponent n. So since we have the same base a, all we have to do is to subtract the exponent of the numerator by the denominator. Subtract the exponent of the denominator by the numerator. So here it is, a raised to m minus n. For example, if we have, let's say, b raised to 3 or b cubed, then divided by b squared, all we get is b, just copy the same base b and subtract the exponent. So the exponent of the numerator minus the exponent of the denominator. So 3 minus 2 is equal to b raised to 1, or in some way it can be written as b. So that is another rule. Another rule of exponent. We have power raised to a power. Power raised to a power. That means if we have a raised to m, raised to exponent m. This is an arbitrary exponent. We don't know exactly what is the exponent, so we just represent it as by a letter. So if a raised to m and everything is raised to n, this will be equal to a raised to m times n. So a raised to m times n. That means if we have a squared raised to 3, we have 2 times 3. That means a raised to 6. That is the answer. Next, we have also the product to a power. Product to a power. So what is product to a power? Product to a power. If we have a raised to m, then b raised to m, this can be written as a b raised to m. So we just multiply the exponent of a and the exponent of b to m. So that becomes a raised to m times b raised to m. For example, if we have a raised to 2, a squared times b squared, and it is raised to 3, to the power of 3, we get a raised to 6 times b raised to 6. Because all you have to do is to multiply the exponent from outside to the inner exponent. So 3 times 2, we have 6. 3 times 2, we have also 6. So that is the answer. Next, we have 0 power. This is the very simple or the simplest rule or law of exponents. The 0 power. The 0 power, when a number, let's say a, when a letter or a number, let's say for example a variable a raised to 0, it is always equal to 1. Any number or letter or anything raised to 1, raised to 0, is always equal to 1. For example, 100 raised to 0 is equal to 1. 1,000,000 raised to 0 is equal to 1. X, y raised to 0, quantity xy raised to 0 is equal to 1. Except if and only if xy raised to 0. If the expression is written this way, we can have only this y will become 1. So our y is 1. It doesn't affect x. So the answer for this is x. So x y raised to 0 is x. Just remember 0, the 0 exponent or the 0 power is always equal to 1. Next, the negative exponent rule. Negative exponent rule. If we have a, let's say a, raised to negative 2, so we are going to use arbitrary letters. A raised to negative n, this becomes 1. Just put 1 on the numerator, then this whole thing right here will become your denominator. Okay, a raised to n, and omit the negative sign. So that is, for example, if we have a raised to negative 2, this becomes, just put a bar sign, put 1 at the numerator, on the numerator, then this whole expression right here will become your denominator, a raised to 2, and omit the negative sign. So that is, for example, another example. What is 2 raised to negative 2? So put 1 on the numerator, then the whole expression right here will become your denominator. So 2 raised to 2, then omit the negative sign, that becomes 2 raised to 2. What is 2 raised to 2? Meaning 2 times 2 is equal to 4. So the answer for this is 1/4. Okay. The functional exponent rule. The functional exponent rule is used if the exponent is in the functional form. I mean fractional form. The fractional exponent rule is given by a raised to 1 over n is equal to the nth root of a. So for example, if we have a raised to 1 over n, this is your exponent, meaning in fractional form. Okay, so this becomes a raised to 1 over n. This is simply written as, this can be written as the nth root of a. That means your n is the index of the radical. Okay, and this is your radicand, the term, the base, I mean. Here is the base, and this one is your radicand. Okay, this is the index, and this is right here is the radical symbol. So if we have a raised to 1/2, this becomes square root of a. But remember, this one right here, the 1, the numerator of the exponent, is just your exponent of the radicand. So since a is raised to 1, so we don't have to write 1, it will be left as a. So that is a, if a is raised to 2/3, so this becomes, this is your index, right? Cube root of a, this is your exponent of the radicand, raised to 2. Another example, if a raised to 1/4, this becomes, this is your root. So we have 4th root of a, the exponent of a, so we don't have to write it because it's already 1. So a raised to 1/4 is just 4th root of a. Another, what if we have this one, a raised to 2/4, 4. So 2 over 4 can be reduced into, we are going to divide both sides by 2, can be reduced to 1 half. So a raised to 1 half is equal to the square root of a. Example another. We're going to use numbers. So what if we have 2 raised to 1 half? So this becomes, this is your index, square root of 2. That is, so exponent is just 1. What if we have 4 raised to 1 half? So this becomes square root, this is your index, square root of 4, and this is your exponent. Since 4 has the exponent of 1, we don't have to write it. So square root of 4, square root of 4 can be written as 2 raised to 2. Then cancel out the exponent 2 and the radical and the square root. So this becomes 2, meaning the square root of 4 is just 2. So that's all. That's the law of exponents.